Okay, so, hi, good evening, everyone. Welcome back to transportation modeling class. Uh, Today's agenda is for you to update your progress report, and then we will discuss about mode choice and model split using logistic regression and the importance of public transport. And if we have time, so we can proceed with traffic assignment and shortest path. Okay. So my question to you is whether you want to present it in the beginning of the class or in the end of the class. Anyone have opinion? Are you ready to present or later? Oh, just agenda for today. Anyone want to present first? Can you hear me? Oh, can you hear my voice?
Yes, sir.
Oh, okay. So, are you going to present now in the beginning of the class or in the end of the class?
It's better at the end of the class, sir.
Okay. Right. Okay. So in that case, let's start with mode choice. Okay. Uh, a few weeks ago, before we take a lot of holidays, we already discussed a little about modal split. So can you see my slide? The purpose of mode choice, okay, is to determine the number of person trips made by each mode of the travel. Okay. So the input is basically the OD, origin destination, okay, from the trip distribution. And then the output of this model supposed to be the same number of trips, person trip. It now separated by mode. So Dij, I is the origin, J is the destination. Okay. And of course, you have many mode choice factors. Okay. So the output will be mode, okay, the number of trips by each mode. Yeah. Mode in here is the number of probably vehicles, maybe pedestrian, maybe bike, okay, using bus or train. So these are the mode choice. Okay. Now, these are the factor that you can use for mode choice. Okay. So one is about trip maker characteristics. Okay. The other one is trips itself, the characteristic of the trip itself, and maybe about the transport facility. Okay. So the most important mode choice factors are probably the travel time and travel cost. Okay. So what is the purpose of the trips? What time of the day? So we need to ask this question and then put the result from the questionnaire, okay, into a table. Okay, and then you can use these factors, okay, and to create a model. So this is the transport facility characteristics that we discussed here a while ago. Okay, so the most important, of course, the travel time and travel cost. Basically, this is generalized cost. You can divide it into quantitative, with this tangible factors, or intangible factors, including comfort, reliability, and so on. Okay, and what model should be used? Okay, so probably the most useful model for mode choice is usually what is called logit model or multinomial logit model. Okay, so you go to refer to Moodle. Okay, and from there find the so you can start to see the lab, okay, with this mode choice based on multinomial logit model. Okay. Yeah. So I'll show you. We go to okay. After this meter, okay, and then 50 here, this one. Mode choice based on multinomial logic model. So when you click this, you will have this link, and when you click the links, you will have the laboratory. So you can use this lab. Okay. Of course, the easiest way is to start the tutorial. You select the sample. Here is the sample data that you can have. So these are the few examples of transportation and other data. Okay? And then you click calibrate this button, okay, to fit the model. And then you review the equation. Yeah. So example here, this is the data that I provided, just 3 data. So when you click the calibrate, yeah, it will give you the model. Okay. So it will give you the model calibrated values already. Okay. And these are the, for example, using cars, probability using bus, and probability using bike, because these are the 3 model that you give, 3 data that you have. Okay. And then now you can go into the detail for each model. For example, utility of the car is 0.07 here. This is the same thing, we repeat, but we have the t-test, the t value here. And then this value, this is already cut, okay, only 3 decimal digits. So if you want the actual digit of model parameters, these are the values. And there are several performance tests that you can use. So log likelihood, R square, that they could test. So if you don't understand this, there's an interpretation down here. Okay, so you can check. And then after that, you can predict. Yeah? So once you review the equation, you can predict the result. Okay, so to predict, of course, you need to put the input. Yeah? So example here, I have 35 and high. So I just copy this and put here. Yeah. What we want to predict is actually the mode, right? So the last column is supposed to be the mode, okay, or the class category. Okay? And then we predict that it will give you the prediction the car is 95% plus so. And it will also create a probability table based on the data available and what is the possibilities. Okay. And once you calibrate, of course, so the accuracy is 100%. This is called confusion matrix. This is the true value down here, and these are the prediction. Okay? When you get the correct result, you're supposed to get in the diagonal. Okay, and there are several performance matrix. Okay, and if you want to understand this, so just read the interpretation here. Okay? And there are several charts. Okay, so I hope you can use this. So I make it for you. Okay, and say you have transport data here, or data that we have. Here we have car, bus, or bike. So when you calibrate, of course, the result is different. Okay, and you can also predict them. This one is still 100%. So you can also validate. Aside from calibration, you can also validate. So when you validate using K-fold validation of 1, that is the same as calibration. So say you have, I put it 5, and then you click validate. What is so in here, even with K5 is 100%. So this is mean the model is quite good. Okay, and of course, optionally, you can select what method to compute this. So by default, it will use gradient descent, but you can also use other model. You can also save the model that you have already calibrated and then load and predict later if you want. Or you can change the theme to a different color. Okay. Okay, so I hope you can try this maybe a few minutes before we continue. Okay. And then ask me question if you have any question. So go ahead, give me feedback. If it's something useful for you, or initially I want to give you Excel, so but it's more complicated to use Excel. Okay? And there are other program already. Say you are using SPSS, or you can also use Python if you want. But probably some of you will become afraid to programming. So I provided for you this one. Okay. So all you need to do is copy and paste your own data, okay, and click the button, and you get the result. So go ahead and try with different sample or data. Okay. So here, example, I put iris. Iris is 150 data of a flower. Okay. So we have, this is usually used for standard test. Okay. So these are the name of variables. Okay. Sepal length, sepal width, sepal length, sepal width, and these are the three iris flowers. Okay. So we just put it into 0, 1, and 2. Okay. Can you see the last column here? Okay. So when you calibrate, okay, so you get this result. So, okay, these are the probability of iris 0, and the utility is this value. Okay, so, and then the t value is here. Okay, And if you want to predict, then you can get a prediction. So not everything is correctly predicted. So there are certain data, you see this one in the red, that means they are not 100%. Okay. The more data that you have, usually you cannot get 100% correct, even during calibration. So, but it's quite good. Accuracy is about 90%. Yeah. And there are certain error. Yeah? So the true value is 1, it predicted as number 2. And the true value is 2, it predicted as number 1. Yeah. 3. Okay. Other data that you can use, for example, here, whether they will buy computer or not, based on the age, income, student, whether they are student on what is their credit rating, and the class, what we want to predict is whether they will buy computer or not. Okay, calibrate this, okay, you get the model. Okay, and then from here you can predict now whether if you are young, medium, yes, the credit rating is yes and excellent. Okay. You are student and excellent credit rating, whether you will buy or not. So the prediction is yes, and then these are the probability. Probability yes and probability no. Now, to give you more understanding, I give you example of mammal. Yeah, whether they are mammal, reptile, fishes, amphibian. Okay. Look at this point. The class is always category. Okay. Whether then the other variable, the input, can be numbers or category. Okay. But the class is always category. Okay. So when you calibrate this, because we have 1, 2, 3, 4, 5. So we have 5 types. So whether mammal, reptile, fishes, or amphibian. So then it will give its model. Yeah. Of course, now you can change this based on your own data. Okay. Again, once you have that, so you can predict. You just input your own data and predict. Then you can get the probability of its label. The interpretation is already here, okay, based on your own number. So, and also the performance metric, the interpretation also already here. Okay. Okay. Please try. And with this, you can use for your own data. Okay. So all you need to do is just copy and paste your own data. Is there any question? No, no question at all. Did you try? Did you try with your own, with any of the sample data and click the calibrate? Okay. So you need to input the data, and then the last column should be your class. So the class in here is the mode vehicles. Of course, because these are generic model, so you can use for any other data as well. As long as the data is categorical, so you can create the model. Based on the model, then you can predict what is the category. Okay. So that is the basic idea of mode choice. So come back to the slide. So these are the data that or variables of the data that you can input. Okay. Then once you have the data, okay, then you can put that into the model. Now there are 2 types of mode choice. because your data is trips between zone, okay, this is the, then you can create model based on that trip, or you can have data based on household or based on individual. Okay, and this is what is called ecological correlation fallacy. Okay, so if you use a trip, okay, on the zonal information, so from zone one zone to another, you basically get the mean, right? You basically get the average. Okay? So you aggregate first, and then you get this point in blue. Okay? This is the point that you put, and this is the next point in another zone. There is possibility when you connect this to the tangent is negative. You see, okay. But when you use this aggregate based on household individual, okay, in zone A, okay, based on income and vehicle trip per household here. Okay. So this one is actually positive tangent. And you see, the green part also, okay, household income versus the vehicle trip per household, they are also positive. But if you use only the mean, okay, so then you get negative slope. Negative slope means the trips decrease by the income. Okay? But in reality, the trip should increase by the income. So with this, we say that look at this. This is not as much as possible. Okay, use disaggregate method rather than aggregate method. Okay? So this is better. Okay. So now, once you have the value from the trip distribution, okay, then you can use Logit model a while ago. Okay, so there are proposals, okay, about Logit model if you have only used two modes and your factor is only one, which is cost. Okay, so this old proposal, they create what is called diversion curve. So diversion curve is this red S curve here, okay, which is based on exactly the same, yeah, or like our model OLCO, with this binary Logit model. Okay, so the only difference is now the probability is divided, yeah, between the actual trips divided by the total trips. Yeah. So the actual trip of one zone divided by the total trip of all zone. Okay. Now, if you have two costs, okay, then you can also take the difference of the cost. Based on this, we can calculate the probability, okay, using this multinomial Logit model. Okay. This is in this case binary Logit model. Okay. The model is like this. Okay. So probability with this the trips of the mode divided by the total trips, yeah, from one origin I to destination J, okay, is an exponent of utility. Yeah? This beta CM is basically utility divided by, again, the exponent of utilities for all modes. Yeah? Yeah. K here is all the modes. So this M here is just one mode. Okay. So in case of binary, okay, you can use binary Logit model. So it is much simpler. So basically you have two utility. Okay, so U1 and U2. And then based on this, you can also use simplified method. Yeah. If you have more two more than 2 modes, okay, then you separate utilities as this kind of similar to multiple linear regression model. Okay, this is exactly what you see in the lab a while ago. Okay, so you don't need to worry about the modeling itself. Yeah, as long as you understand what we model is actually the probability of choosing that mode, okay, based on the factors. And when we calibrate, what we get is actually this value of alpha, beta 1, beta 2, and delta k. Okay, so this is an example. Let's say you have only 2 mode, either car or bus. Okay, and we use only binary logistic model. Okay, and we have only 2 variables here, which is travel cost and travel time. But this is not the usual travel cost and travel time. This is the delta. Okay, so the difference of travel cost and travel time. So with this, you can this is the default value, okay, which is current. So the travel cost of the bus is 1.7. The travel time is 0.75 hours, 5 minutes, and the car is this one, and so on. And then if you know this is one of the table, okay, one of the cell in the table of trip distribution. Okay. So you have 1,000 trips, example, from zone I to zone J. Okay. Now, how many people will use bus? Okay. And then we can simulate now, because now you have the variables like travel time and travel cost. Then you can simulate, of course, the travel cost. Okay. So if the fare reduced to 1.5, how many people will use bus? Okay. Additionally, if you have, say, congestion pricing toll, again, this one is about the cost. Okay. How many people will shift from the car to the bus? The idea of mode choice is basically you want to make the middle income people shift from using private vehicles into public vehicles. Okay. So with that, you can, because they are based on difference, okay, so you can get the difference first in the travel cost and travel time, and you input the value, okay, you will get, say, 38%, okay, and then you multiply this probability with the number of trips within that cell, so you get, this is the number of people that will use bus in that to from that origin to that destination. Okay. Then again, you can simulate, okay, what will happen if something changes. So in here, for example, if the bus fare change become 1.5, okay, then you change the input, okay, and you get the probability value. Okay. Same thing if you have another policy, for example, congestion pricing. Okay. So in this case, again, you input, change the input, and you will get the number of additional people. So apparently, in this example, the change of fare actually a better result than congestion pricing. No. Congestion pricing saved 13%, while the improvement of the fare only improved 2%. So congestion pricing produce more result than improve of the fare. Okay, so you can start to see the value, the merit of using this. Now, the same model, okay, because now you can input different variables, so you can use for different application. Okay, so you start to simulate whether there is congestion pricing, whether you have a new highway or new transit systems. Okay, So whether you have some fuel tax increase or decrease, okay, and so on. So you can use this kind of model with this multinomial Logit model. Okay. So a while ago, I also discussed about the likelihood ratio. So what is that? Okay. So that is similar to R squared in regression. So the basic idea is to compare the two models, full versus reduced. Yeah. The full model example like this, up to 3 variables. If the reduced is just 2, okay, then there is some df. df is degree of freedom. Okay, it represents the number of parameter minus 1. And the H0, okay, the hypothesis is, of course, the same as full model. Okay, when beta 3 is 0. So, and then you can also use the t-value. Yeah? The t-value usually, the absolute of 3 value must be less than 1.96. The absolute value of the t. Yeah? So this is absolute value. Now, the sign of the parameter, okay, here must be correct, yeah, intuitively. Okay? So this table is very useful to determine whether some factor will be included or not. Okay, some variables should be included or not. So check the sign first. Yeah, if the sign is correct, okay, then check the t-test. Here is the t-value. Okay, whether this is significant or not. Okay. So if they are significant, and these are policy variable or not. Okay. Policy variable is something that you can use for control, for decision, something like a while ago here, the fare or congestion pricing and so on. So what is non-policy variable? Non-policy variable is something like here, the family income, education level. These are something that you cannot control, right? So there are many variables you can input in the model, but they are not policy variable because you cannot control. Okay, these are the policy variable because these are the variable that you can control. You can create policy based on this variable. So identify within your model which are the policy variable, which is something that you can control, you can change, right? So I hope you understand. These are the socioeconomic factor you can input, but you cannot control this. They are given. Okay? So when this is policy variable, then of course you need to include. But if it is not policy variable and they are not significant, you may reject them. You just exclude the problem. But when the sign is wrong, okay, then you are in have a problem. So if they are not policy variables, simply you reject. Okay. But when they are policy variables, they have wrong sign and the t-test is significant, then you are in a big problems. Okay. Probably you should not use this Logit model. Maybe you should use other model. Okay. So again, Logit model is not the only model that you can use. Okay. So let me show you other model that you can also use. Okay. So if you go to the same lab, okay, right here, right? You go to the same lab, okay, and then you just remove this one, address, okay, and okay, go to the tutorial. This is the main page, right? And you go to ideal flow network, okay, and go down to this one, table classification, supervised learning. And this is another model that you can also use. How it works. Yeah. So, yeah, this is another lab that you can also use for more choice. These are the example. The same thing. This is the example of other data. Okay. So I already put transport mode here. The same data as a while ago. Okay. And then all you need to do is this is the parameter that you can play. Okay. And then you can train. This is calibration. Okay. So accuracy is 100%. This because we have 10 data. Okay. It predicted, okay, based on that class. And these are the model inside. So if you don't understand what is this B1, B2, this actually has value. Okay. So whether the gender is male or female, okay, B1 is basically car ownership is 1 or 2, and so on. And then once you have that value, okay, you can predict. Okay, so here is the example that you can predict. Okay, so if you predict here, so I calibrate, train, and then I can randomly create the data, and then you can predict here. Okay, the same. So you get the class and the probability, basically. Okay, you get exactly similar to the multinomial logic model, but there is some additional. What is the additional? Because IFN is generative AI, okay, now you can also generate. Okay, so I want to know, okay, what is the for the car, for example, give me, okay, you can click this value, okay, so you can see the example of data for car. So you can create data. Okay. The model will automatically generate data for you. Okay. So what is the people who usually use pass? So you just click here, you can get different values. Okay. So these are alternative choice. And there are many other models as well, so that you can use for more choice. Okay. So up to here, is there any question? We can play with those two labs. Yeah, if you want to use if you know how to program, okay, uh, instead of just using this in the web, okay, you can also go to the GitHub, the Ideal Flow Network, or you can search in Google Ideal Flow Network in GitHub. There are several, and these are the, okay. Okay, so these are the Ideal Flow Network in Python, so you can check. So let me go to documentation. Okay, so these are the example of computation exactly the same as a while ago. So classification data using IFN. Okay, so you can just copy and paste this code in Python. Okay, and these are the example of data a while ago, mama. Okay. All here is just binary example, right, of mama, and these are the variables, the beginning and the end is using the class. Okay. And then now you have more power because you can program it, so you can copy and paste this value and also the prediction. Okay. You can also generate directly random choice, okay. And you will get similar result like in the website. Okay, but because you are having a program, so you can go to the detail, much more detail. Okay. And this is for mode, transport mode, the mode choice. Okay. Again, you can create this are the data, okay. And you can start to put the name, okay, and you can get the actual X value, which is only the data without the label, and these are the extract of the Y value, which is the classes, okay. And then you can start to prepare the data if you want. Okay. So with that, again, you can calibrate and build your own model. Okay. Similar. Okay. And after that, you can generate, okay, the result here. Okay. So I hope this is good enough for you to play. Okay. So any question, any feedback? Any feedback? Say, tell me what you understand and tell me what you don't understand so that I will get some feedback from you.
Uh, so basically, when we categorize like in a yes or no variable, we use binary values, a 1 and a 0. And then for the other variables, in terms of if it is numerical, we can use regression or quantitative variables. But since for the logit model or the utility functions, we're using qualitative variables, the much more applicable would be the chi-squared
Yes.
instead of the r-squared.
No. Okay, so if you have data, okay, in data analysis, okay, now in data analysis, you divide into two parts. Okay. So whether your data is actually, okay, let me draw in the screen or in the sorry, I will share my notes. Okay, so your data, okay, consists of input and output, correct? Okay, plus output. Okay. So I will call the input as X, okay, and then the output is the Y. Okay. So if you have this kind of data, input and output, so the terminology is called supervised learning. Supervised learning. Okay. Now, supervised learning have two possibilities. Okay, one is called regression. Regression. Okay, the other one is called classification. Classification. So what's the difference between regression and classification? Right? The difference is actually in the output here, the y. Okay, in regression, the y, okay, is numerical. Numerical. Okay. In here, the y is label. Okay. So that's the only difference. How about the input? Okay. The x is the same. Yeah. The x can be binary, okay, numeric, or
Yeah.
label.
Categorical or latent.
Categorical. Okay. Or categorical label. Okay. So it doesn't matter. The input doesn't matter. The output matters.
On the model, sir, if we're using categorical data, we assign numbers to each category to do
No need.
regression, for
No
example.
need. No need. That's very old.
Ah,
Okay. If you put here, the model automatically compute that for you. In fact, if you build using that, say in the website, automatically will calculate. For example, if you are using binary, it will create two variables automatically. If you are using categorical, automatically will create the number of categories for you. Okay. The very old way is, yes, you need to manually put into binaries one by one, but no need. Okay, that's very old way of thinking. Right? We already solved that problem. Okay, so independent variables, okay, the x, right, in the logic model can be continuous, categorical, and mixed. That's correct. Okay, but the dependent variable, okay, it is the output, must be categorical label. Okay, it is clear. So when you said chi-square and so on, these are the computing the degree of freedoms. Okay, it's not necessarily related to this one. So I hope this is clear. Okay, so if you have more question, you ask so that we can have more discussion. That's better. Okay. Go ahead. Is that yes, John?
Hi, just clarification. The lab, can I just
Okay,
share
you
this?
can share. You can share. Okay. Go.
Just wondering where this figure coming from or what this figure represents.
Okay, then you can predict, right? You already predicted. Okay, very good. So
35 and 6 are where this figure
above that, can you go up to the data there? That is the 36 and something is the travel time, cost, and convenience.
I see.
Okay.
Like the average.
Yes. So you can put any type, yeah, any data type. And if you look at the model, okay, say go to another data that actually categorical, it will create different value for each label automatically.
This one.
You don't need to binarize it. In the old way, yes, I understand. So probably some of your teachers still doing that because that is the old way. I understand that. Okay. Nowadays we already solved that, so automatically you can calculate. Better?
Sir, where is the link for the last lab you presented?
Oh, so search online, okay, IFN, ideal full network, online ideal full network in Google. Okay, and go to supervised learning. There are many labs there, so go to the supervised learning. Okay. Using IFN, you can also play, we can also create music, yeah, or generate music. So you can do a lot of things with that. Nowadays, I'm developing the automation. So using IFN, we can create automation that your computer can run by itself. Did you find the lab? So when you use classification, okay, the output is the choice of the label. So for example, you can use this for decision. Okay, you can use it yes or no, up to you to decide. Okay, in the iris data a while ago, the value is 0, 1, 2, right? Look like they are numerical, but they are actually categorical. Okay. The way you represent the data, whether they are numeric or not, it doesn't matter. The actual meaning matters. Go ahead.
So sir,
Yes.
when we input new data, set of data here,
Uh-huh.
what category should we use? Is it the select sample data, iris, transport model
Oh,
one?
it's up to you. It's up to you. These are the example of data that you can use. Of course, in your project, you use your own data. You collect you collect your own data, isn't it? Okay. So
Yes, sir.
I only provide the tool, so you use it. Okay. So for understanding the concept, you can use the sample data and then just click, and then you can start to see the result. If you study data science, data mining, business intelligence, for example, there are many methods, yeah? more than 100 methods of similar classification alone. There are more than 100 methods. Okay. It's so strange that transport engineers is only stick with one, which is only a Logit model. We should go out from this uh, way of thinking. Okay. In fact, if you can use Python, you can check the, for example, decision tree. Okay, using decision tree, you will create the rules, not just probability. You will get the rule. Okay, what make that category happen? So each of the technique have different, have certain strength and weakness. So I hope this is useful enough. Okay, give me feedback. What do you understand and what you don't understand, so that I can grasp your understanding. So in your data analysis, okay, how do you aggregate? Aggregate meaning you take the average. You have data table, okay, and how do you aggregate? How do you take the average? So these are the common problems. So the naive approach, usually you have each of the columns in the independent variables, the X, you take the average. After that, you compute the probability, yeah, for each mode. So this is naive approach. Okay. Another actual probability approach is to compute the probability for each observation, which is each row, and then you take the average probability of the same mode. Okay. But better approach, or the best approach, is actually to separate first. Yeah? You separate the data by socioeconomics and trade purpose, okay? And then you compute the probability for each group, okay? And then you take the average probability of the same, like this second approach, okay? So if you just get everything at once, so you get a problem similar to ecological correlation or this one, because you already put the aggregate first, then you lost information. Okay. The problem here is once you aggregate, you lost information. So this is what happened. Okay. Now, this is the caution. If you want to build any model using category like this, yeah, there is very important assumption. This is called IIA. So IIA is independent irrelevant alternative. It says that when any two alternatives have non-zero probability of being chosen, the ratio of one probability over the other is independent and unaffected by the present or absent any additional alternative of the set. So the alternative must be independent. Okay, so when you say bus and car, okay, and train, they are independent. But when you start to put the alternative as something that actually dependent, for example, you said red bus and blue bus. Yeah, so say in the city with 50% trip maker, okay, choose a car, and then 50% choose bus. Okay, so in here, between car and bus is supposed to be the same, right? 50%, 50%. Now the bus is painted into red and blue, okay, with the same value. So in this case, the blue bars and the red bars also the same. So then if you put it into multinomial logit model, because you put it exactly the same, so you will get one third, which is incorrect, right? Because they are actually 50% bus and 50% car. You understand? So it is a mistake because the three choice are not independent. Yeah? This is violated of the independent relevant alternative condition. Okay? Your category must be independent from each other. Okay? Next. So these are the few charts that you can see the mode choice in other countries and the trends. Okay? And these are the chart between the private vehicles market share and public vehicle market share. So basically Asian cities is more than European or American cities. So we are in the good shape for public transportation, especially in Manila, in Philippines. People think that mode choice in developed countries like the US or Europe is better. Not necessarily. Yeah? Actually, in terms of mode choice, the number of people who use public transport in the Philippines is more than in the US. Okay. Yes, we are still lacking a lot of things like the regularity, comfortability, and so on. But in terms of the number of market share, we are actually better, much better, yeah, compared to the US. Okay, so now it depends on how do you see the metrics compare. Okay, so these are transit use for car ownership for different cities around the world. Okay? And these are the subway, yeah? Largest subway in the world, the very old data. Okay? And let's say now you know PCU value, right? A passenger car unit value. So each country have their own standard. So this one I got from one paper in 2017. Spain do certain studies of PCU values in the Philippines. Yeah? So these are the result. So trucks is about 3. Okay? The bus is about 3 also. A car, of course, 1 because this is the standard. And van is probably 1.5 of the car. A jeep is about 2.2 times of the car. Yeah? The same thing with others. It's about 1.5 to 2 times of the car. And motorcycle is 1/4 of the car. Yeah, about 1/4 of the car. So with that value, we can start to compute. Yeah? Numerical example, how the change of vehicle occupancy matters. Okay? Suppose we have 2.5 kilometer link from A to B. Okay? Suppose you have demand of, the demand is 13,500 person per hour. Okay. Now, we know that the link capacity is about 2,000 PCU per hour per lane. Okay. And car occupancy is about 1.5 person per passenger car unit. So basically per car. So question is, how many lanes is needed to accommodate such demand? Okay. And what is the congestion level using that number of lanes? Okay. We already learned grid shift model in the beginning of this class. Okay. Last time. Okay. Then you can use the grid shift model to decide what is the travel time if you know the maximum speed. Okay. So in this example, say we use only car. Okay. So the demand is 13.5. The length is 2.5. So when you input all of this data, so we can calculate the actual demand. Okay. We convert from people per hour, right, into PCU per hour. So we convert from people per hour into PCU per hour. How do you get that? If you know the car occupancy, yeah, on average, okay, 1.5% per car. Then you can get the number of PCU per hour. Is it clear? And then if you want to know the number of lanes for that demand, so because now we are already using PCU per hour, and we know the capacity, so 9,000 divided by 2,000 is 4.5, right? So the number of lanes must be discrete, so we put it up. So we have 5 lanes. So the lane capacity itself, because we have 5 lanes times 2,000 PCU per hour per lane. So you have 10,000 PCU per hour. Okay. So what is the congestion level? So congestion is basically demand per capacity, right? So the demand is already here, 9,000 PCU per hour. Okay. And the capacity is already given here, 10,000. So then the congestion level is 90%. So if you know the congestion level 90%, okay, then you can calculate the travel time, okay, using grid shield. We need to know the length. So here, length is already given, 2.5 kilometers. Okay, and we need to know also the maximum speed. So again, we are given 60. So in that case, we just input. Yeah? So we can get the travel time. Yeah. So if you know the congestion, you can get the travel time. And so on. Okay. Now, see what happened if all the people, so 100%, instead of using all car, now all of the people using bus. Okay. So let's assume bus occupancy is 30 people per bus. And this is small bus. Yeah. The large bus usually 60 to 100 if you allow standing. And 30 is mini bus. And then let's put the value of conversion 3 PCU per bus. Okay, this is based on this kind of table a while ago. See, bus is about 3.3, isn't it? So truck also about 3. So I can say that about 3. Yeah. So let's put that 3 value here. So what happened to the same problem? Okay, the same demand, 13,500 people. Okay, so if you have 13,500 people per hour, and now you know the occupancy of vehicles, which is 30 people per bus. Okay, then you have 450 bus. Okay, 450 bus per hour, and multiply by 3 PCU per bus. So you get the demand is actually only 1,350. This is much lower than the 1 lane capacity. Yeah. So even only 1 lane, you can already get to pass all these 13,000 people. The same demand. Okay. What is the congestion level? 67.5%. You see here the difference, very contrast. Yeah? If you use all car, the same demand, 13,000, okay, you need 5 lanes, and the congestion level is 90%. Right? Now, if you use bus with the same demand, Okay, you only need one lane and still only 67%. Okay. Of course, from there you can calculate the travel time. Yeah? The travel time, because they are very short, so the travel time difference is not so much. Yeah? This is just 3 point something minutes, and then here is also 3 point something minutes. The difference is not so much in terms of travel time, but in terms of the space, the number of lanes matters so much, right? Of course, if you put the same number of lanes, 5 lanes, then the difference of travel time drop a lot. And you can calculate by yourself. Okay, so now I want you to do is to do this. In similar computation, can you calculate what will happen if the bus user is a while ago 0%, yeah, all using car, and then 100% using bus? So now can you put gradation, yeah, from 10%, 20%, 30% up to 100%? Okay. Can you calculate? Okay, so then you plot, okay, something like this in terms of the space. This is the number of lanes, and you also plot the travel times. Okay, so I hope you can do this in short while practice. Okay, and then you can also calculate the time saving. Yeah, time saving from all car scenario, okay, as the number of percentage of the bus user. Okay. Is it clear, the task that you need to practice? If not clear, you ask first.
Yes, sir. We recreate the graphs.
Correct. Right. Okay. So please practice. Yeah. So once you finish, you share your screen. Okay. And then you can claim your presentation. Okay. Maybe 5-10 minutes. Okay. Yeah. So if you look at this, you just input this data, the one in yellow. We know the demand is 13,500, car occupancy 1.5, and then lane capacity and the length and the maximum speed, right? So from there you can calculate the demand, okay, and number of lanes and lane capacity and congestion level, and then you calculate the time. The travel time, of course, in hour, because everything is in PCU an hour, kilometer an hour. So then you convert to minutes and seconds if you want. Okay. Then we can also put what happens if you have passed 100%. Okay, so these are the input. Okay, bus occupancy is 30, PCU conversion is 3 PCU per bus, right? The same demand, so just copy. And car demand in this case is 0. So from there we can calculate the actual value. Okay, the saving is based on the difference between the car 100% and this bus. Yeah. Again, in terms of the time saving, because we reduce the space, so not so much, but in terms of space saving is significant. Yeah, from 5 lane become only 1 lane. Okay. What's the meaning of saving of the space? That means we don't need to demolish your house, someone else's home, just to create the road, isn't it? So with that, you can start to create a data table. Okay. So you can create data table. This one, you just copy from A6 here is the percentage. Okay. And then now you can, what do you want to know? Say the number of lanes, traffic, and then savings. So these are the things that you input. Okay. After that, you also input the possible percentage, yeah, of the data. Yeah. Then all you need to do is copy all of these. Okay. And then use data table. Yeah. So you have data, okay, what if analysis, and then use data table. Yeah. So this you can get this result. Okay. Once you get the result, of course, what all you need to do is just to plot. Is it okay? Okay, just do it. So once you know how to do this, so there is an assignment in Moodle. Okay. So you can also do the assignment. I want to make sure that you know how to build this first. That's why I give you time to practice. Yeah, don't do it one by one. Okay, you use data table. That is faster. Go ahead if you want to share your screen. So if you are not sure how to use data table, then I will give you the link in my tutorial that I put in the chat. That is how to use data table in Excel. Yeah. And in this case, you only have one variable, which is the percentage of the bus. So you can use just one data table. Don't forget the number of lane is discrete. So in this case, you need to use sailing. Anyone want to share screen? I give 3 chance. 3% can share the screen. You're supposed to get the percentage of bus rider, yeah, from 0 to 100%. Okay, so that means from the total demand. From the total demand. So the total demand in here is 13,500. Okay. So that means if you have 13,500, what if you put the percentage is 100%, that means 13,500 will use pass. If you put 10%, that means only 1,350 people will use pass. So the rest is using card. Right. Okay, go ahead. You can share your screen. Go ahead. Okay.
I think
Yeah.
it's lagging, sir.
Still sharing. I did not see yet. No problem. Just take your time. Yes, you may get error in the computation of travel time in the zero because of negative. Yeah, so only the first line, but after that, no, because you cannot divide by zero, or you cannot take the square root of negative number. And can anyone see Joben's screen? I cannot see it.
Still loading.
Oh, okay.
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 Sir, can I show mine instead?
Okay. Cool.
Okay. Here's what I did.
Okay.
So I did every 10 percentages. So this one is for number of planes versus percent bus users.
Okay.
Then this one is for number of lanes versus speed. So it's uh, an erratic going upwards. And then percent bus users versus travel time.
Okay.
So now it's going
Right.
downwards. And then lastly is time savings.
Okay. Saving. So you just need to put the meaning of its axis, yeah?
Okay, sir.
The label. Okay. And yes, I think you how do you put this table in?
Uh,
Are
Sir,
you
actually, I completed
one by
the
one?
share in demand of bus as well as the car. Then you get number of lanes as the total demand divided by the capacity. So, of course, you need to convert into PCU first
Right.
because both should be in PCU or number of persons. You can also do that.
Okay. How about this one?
Which, sir?
This table.
Yeah, I set 10. I'm actually trying to set up it as a VLOOKUP, but I have no time. And then just call in the values
One by
which
one.
10% ban.
Okay, you can use data table. You never use data
And for
table.
the speed, it's travel length divided by travel. Data table. Okay, I'll also use that.
Okay, try to use data table. It will save your time next time also.
Okay, sir.
No, this time is okay, but next time when you use data table, okay, when you have this kind of problems, use data table.
Okay, sir.
You only need to equal to that value that you want in the first row only. After that, you fill in the percentage of dashes in this case now, okay, and then you highlight everything, okay? And then click OK in the data table. It will generate value for you.
Okay, I'll try that one, sir, and then show
Yeah.
again my
Okay. Okay.
Thank you.
Good. Okay. So, anyone else want to share? Go ahead.
Sir, can I try again, sir?
Okay.
But I think this is wrong. I did the long method, sir.
No problem. So percentage of the bus, okay,
It's
and then
somewhat same, but
yeah, some the graph
I
seems
did
like
the long
yeah,
method, sir.
correct. So the demand is now changing like that, and then you put it into PCU, and then you get the number of names. Yeah. Okay. So
Is it correct, sir, that I always use ceiling?
oh, you can use sailing. The only part that you did not compute is just the travel time, right?
I just computed, sir,
Yeah,
the
that's fine. Okay, so you continue later with the travel time.
sir.
Yeah, very good, Chopin.
Thanks, sir.
Come on, who else want to share? Yeah, yeah, I think you got this. Okay, so okay, one more. Who want to share? You're not familiar with the data table, so try to use data table. It will done magic for you.
Sir, later, can we have the copy of that Excel, sir?
Oh, sure. No problem. I can put in the
Thank you, sir. We will
Moodle.
study the data
Yeah, I can put in
because
the
I
Moodle.
did the long method.
No, your code is okay. You just need to add the travel time. Go ahead, one more person to share. Who want to share? Oh, number of men. Travel. I think I will put now so that I will not forget. You can refresh your browser. Okay, I put that the Excel sheet in Moodle for computational object transport. So maybe you can take a look. I hope this is useful for you. So I'm using data table. Yeah. Yes, June, go ahead.
So I just computed the demand and
Okay,
congestion
so
level.
you want to, okay. Share your screen, June. Okay, good.
It's okay. But I I just computed, sir, the demand and congestion level. And
But very small. Wait, the demand is only 135 PCU. I think you need to put 1,300. This is too small, the value. Can you put this one 13,500? No. In A3.
what?
A3.
I'm sorry.
Mm-mm.
Yeah. Sorry.
Okay, last one second. Okay, so this is a better. And then,
I can have
how do you get the congestion?
it's fine, sir. The
Oh,
demand over the capacity, which is 2,000 per lane.
okay. So
And
look at this. If you have this is lacking of what? Can you see? Yes, this is the demand. Okay, so the bus usage is 10% here, right? So, but the problem is you did not calculate the car.
yes, it's for us.
So you only calculate the bus, but you did not calculate the car. So where are the other, say 13,000 minus 1,350 here in the first row? They're supposed to use car, right? Yeah, that one is 12,000 something. That one is they are using car. So that will contribute much higher congestion level. So the number of lane is not enough.
I see.
So this computation is, sorry, still incorrect.
Yes.
Okay. So you can check the sheet that I give you so that you can start to see. Now this is not correct. Why? Because you only compute the bus, but you didn't compute the cars. Okay. When we say 10% bus usage, that means yes, this is correct, 1,350, but the 12,150 is using cars. That means the congestion level is much higher than this, right? See, 12,500 divided by 2,000, that is like you need to have 6 lane, more than 6 lane. So you need to combine.
Okay, sir.
Do you get the problem?
Yes, sir.
Yeah, the problem you use only for the bus, but did not calculate the total. Yeah, bus and car. Okay, so Joyce, you want to share screen or say something? You are still mute.
Hello, sir. Yeah. I want to share my screen.
Okay.
So I just also used the file. Can you see it? Oh, sir. Wait. Here. Share. Can you see it, sir?
Can anyone see it? Oh yeah, okay, I can see it now.
So yes, I
Percent,
first
okay.
put this is a bash here. So yeah. Then I computed the bus per hour, then the PCU per hour for the buses, then the cars, then the demand total.
Okay,
The
this
link
is,
capacity I adjusted based on the demand.
wait. What is 45 bus per hour?
For 10%, wait, yeah, wait, is this 10%? Or is this the 90? I think this is the private cars share. wait. I forgot the specifics there.
If you have 13,500 people in 1 hour that you need to transfer from one place to another. Okay.
Yes. So
So
yes. Divided.
we have okay 10%
I
that,
yes.
and then you divide by 30. That represent the number of people that you use bus, right? Demand for the bus.
Yes.
Okay.
Yes, sir.
Okay. Can you please enter there? Only.
And then yeah.
What? Wait. Why only? No, 10% is 10% of 13,500. This one, in this,
Hmm.
uh,
10% of 10%. Yeah. 10% of the people who
no,
using bus.
13%,
That was right.
13,500 multiplied by 10%, you're supposed to put it in the bus, not 135, right? Yeah, correct?
Yeah.
So,
Yes, sir.
so this is still incorrect. Can you see? Because you put
Yes.
135, which is supposed to be 1,350.
Yeah. Yeah.
So, yeah,
1,350.
this computation is still incorrect, okay? Say
Okay, sir.
10% of 13,500 supposed to be 1,350,
Oh, yeah.
okay? And then the car supposed to be 13,500 minus that 1,350, so 12,000 something, not 8,000,
Okay.
okay?
Sige, sir. I'll try to recompute again, sir.
Yes,
Thank
yes.
you.
Mhm. Yeah, some of you get it, some not. Leslie, you want to share something?
I'll share my screen, sir.
Yes.
Can you see it now?
The same problem. Uh, the
I wasn't able to get the
Yeah.
cars, sir.
You can get this very easy. Look at it. The percentage of the bus user here, okay, the one that you put 10%, you multiply
Yes.
by 13,500, you're supposed to get the bus demand, right?
Yes.
In here. Here. This one supposed to be.
Yes.
This is not the. What is this? This is the demand for the bus. This is correct. This is not the demand per hour.
Yes, sir. Yes.
Right.
Oh,
Okay, this is correct, but this is for the
bus per hour.
yes. And then after that, you need to get the demand for the car, which is
Okay.
13,500 minus those demand.
Minus 136. Okay, sir.
And then you divide by the occupancy for the bus and divide by occupancy for the car, okay, to put them all in the same unit, which is PCU per hour.
Okay.
And after that, you add, okay, and then you divide by the capacity. Per lane is 2,000.
Yes, sir.
Okay. So then you will know the number of lanes. So,
Mm.
okay, so this is still incorrect. Too small for.
Mm.
So you
Was
see like,
wondering if that's correct, the number of links. That's
no,
why.
because suppose you use bus all, this is probably correct, but if you use all car, you can put zero also in here so that you can get 13,500 of the demand.
Okay.
Okay, and then you will see if everyone is using car, that means they need 13,500 demand. Okay, and put that into car, that is divided by 1.5 occupancy, right? So that means around 9,000. So 9,000 divided by 2,000 PCU per hour, that is 4.5, isn't it? So that is you need about 5 lanes. Yeah. So this is incorrect. So if your demand is 13,500, okay, so you need about five lanes here. I hope you can correct this.
Yes, sir. I'll study.
Okay, thank you.
Thank you.
Anyone else want to share? Yeah, Joyce.
So can I try again? I think I just missed one of the lines.
Okay, no
So,
problem. Oh,
um, so there should be the demand in people per hour. So that's the
yeah,
1,350.
31 is
And then the
per hour. That is for the
yes po,
bus. That's correct.
yes. Then you should divide it by 30 to get the number of bus per hour.
Okay.
And this is the PCU per hour. You multiply it by 3. Then
The demand. Wait, how about the demand for the car?
for the demand for the car, um, I computed it directly. That uh, I going straight to the PCU.
Uh,
Straight.
okay, let's say, uh, can you add one more column of 0 here in the F? Insert one column in the sheet F. And then, okay, and then put it 0 in the A, in the first row.
First row, yes.
In the first row, F1, you put 0.
Ah, yeah, 0%.
Okay. And then now you copy the same formula all down to F.
Wait. Okay, sorry. Uh,
Okay, so
let's
total demand is 9,000, that's correct.
what?
And okay, zero bus, right? Everyone is using car, that's correct, 9,000. And then what is this 8,000 here? F7.
But this should be the link capacity, which should be 10,000.
Okay. So you can
So
calculate this, not instead of typing, you can calculate this, no?
yes, sir.
10,000,
Yes, so maximum. Then I translated it to the graphs. Make
right.
sure it's correct.
So you can, the link capacity will change. Yeah, that's correct. Okay. Okay. So once you have that, you can start to see what happened. What happened? Yeah. Are you still sharing the screen? Okay, so you can practice again. Okay, I hope this is useful. Anyone want to share screen, or we can proceed to the next topic? I think there any problem suddenly everyone disappeared. So, do you still need time to do this, or you want to share your screen, or we can proceed to the next topic? Your choice. Okay, you will just practice later. Okay. Anyway, I share my spreadsheet there in refer to Moodle. Okay. I hope you can use that also for your. And we have assignment for this technique. But of course, because this is assignment, okay, it's a little bit bigger than this practice. Okay, so you have to combine, okay, trip distribution and the mode choice. Okay, in that assignment, you need to combine the two, trip distribution and mode choice. Okay. Okay then. Let me give introduction, maybe just 20 minutes or 10 minutes on traffic assignment. Okay, this is the next topic. So you can go to Moodle. Okay. So now I will share my screen. Can you see my screen? Okay. So in the classical four-step model, we have trip generation, trip distribution, mode choice, and this is the fourth step. Yeah. So traffic assignment. Okay, so this is the last step. In trip generation, you have the land use, okay, and then you want to estimate the trip attraction or trip production from that land use. Okay, so the whole city or the whole study area you divide into zone, okay, and then you check the land use activities in that zone, okay, and then you will get the number of trips, person trips from that zone. So production and attraction, okay. In the second step, which is trip distribution, So you use models such as gravity model. Given the trip production and trip attraction, okay, you want to know what is the person trips from one zone to another. So what you get is OD, origin destination, from one zone to another zone. Okay. In mode choice a while ago, okay. So now for each cell in that trip distribution, okay, now you want to assign what mode, okay, this they will use. Okay. So either they use car or they use bus, they use bike, or they are just pedestrian. So you can start to get the TIJM, which is the T is a trips, okay, from zone I to zone J, which is just one cell, and then you divide into what mode of transportation that they use. Okay. Now in traffic assignment, okay, the one that we have from each mode, now you put them into real flow. Okay, so these are the content that we will discuss. We will not finish today, okay, but I will just give you the idea. Okay, so in traffic assignment, now for each mode, you put it into network, right? So once you put into network, what you will get, the PCU per hour in the link. So you will get link flow. Okay, it's no longer person trips. Now you will get the link flow. That is the purpose of modeling transport, yeah, to get the demand for each link. Of course, if you know the demand for each link, now divide by the capacity of the link, you will know the congestion. If you know the congestion, you can calculate the travel time, the delay, and other performance, including the energy usage, okay, including the air pollution and so on. All of this depends on one number, which is the congestion. Okay, that's why, and the congestion depends on the link flow, the demand of that link. Okay, that's why the traffic assignment is very important. Yeah? In fact, all the other software usually, if you buy the software for transportation planning, okay, what they sell is not the trip gen, not the distribution, or not the mode choice, but actually the traffic assignment, because this is the most difficult. Okay, so I already developed this and give it for free, yeah, in GitHub or also in online. You can also use. Okay. So what is traffic assignment? You know from the trip, from the origin and destination, you know the number of trips. Okay. In terms of mode, that means already in the bus or in the car, and then you convert everything in PCU. Yeah. You already know, okay, how many trips from origin to destination in PCU per hour. Okay, this is no longer bus, this is no longer car, but already in standard dash unit, so we call it passenger car units, okay, which you convert a while ago in that practice. Okay, and of course you know the time, okay, the cost and the number of connections. Okay, in traffic assignment we are asking which path they will use. Yeah, given this number of demand in terms of PCU per hour, which path they will use. Okay, so this is a process of allocating the traffic volume, PCU per hour, to various route of transportation network. Okay, so basically we want to simulate what is the existing condition right now, the flow, and then what will be the predicted traffic movement in the transport network. Okay. Remember, we have the from each OD, yeah, origin destination, you know the trips by mode already. Okay, and then you convert everything into PCU per hour, yeah, not by mode, but now into PCU per hour. Okay, now you have trips from I to J, J to K, and so on. And then when you put that demand by zone, this one's still in zone, right? So now you put it into the actual links and node on the road network. Okay, that is traffic assignment. So of course, in reality, you will get something like this, no? So the actual road network, okay, that you have. So you can download this using IFN transport, okay, either in the online or the Python part. Okay, you can get this network data, okay, and then you can put that into Excel or into GIS. You will get something like this, yeah, whether they are one directional or two directional. Okay, so how to do traffic assignment is actually finding the route. Okay, from origin to destination, say you start from here, it will go finding the route. Okay, the algorithm basically finding the shortest route from origin to destination, and the route not necessarily cycle like this. Okay, so what are the factors? Okay, so remember what we get. Okay, is not what we have from the trip chain and trip distribution and mode choice. Okay, first is person trips, right? And then you convert them into vehicle trips. Yeah, you already practiced a while ago. Okay, if you know the average number of person per vehicle type, so you know the occupancy. Okay, then you will know the actual number of vehicles. Okay, if you know the number of vehicles, okay, and then you know the PCU value, you can convert all of this into PCU values. Okay, and of course there are different demand. Okay, based on the time of the day. Okay, if you want to design, yeah, of course you will design based on the maximum problem. Okay, in this case, we design based on the peak hour. Okay, so if I don't know the peak hour, but I know the average annual daily traffic, AADT, how I will get the peak hour? Yeah, you can estimate, okay, the peak hour usually about 10 to 20% of the 24 hours. Okay, so for example, if your AADT, okay, in one average daily traffic is, for example, 10,000 in that road, okay, that means the peak hour is only 1,000 to 2,000. Okay, so 10% or to 20%. Okay, of course, peak hour will have different direction in the morning and in the evening. Okay, so remember, when you do a trip generation prediction, that is the same as production attraction. Yeah. So when you use traffic assignment, okay, what you will use is actually the trip for origin to destination. So you need to convert from person trip to vehicle trips and then to PCU per hour. Don't forget that. Okay, and then you convert also to get the maximum during the peak hour. Yeah, using these numbers that we have here. So 10 to 20%. If your value is already in daily traffic. Yeah, if you are already in the peak hour, then you don't need to convert into peak hour. Okay, so what is the input of traffic assignment? Okay, you have trip matrix by mode. Okay, that represent the demand. Okay, usually unsymmetrical. Yeah, the peak hour trip matrix is usually unsymmetrical because in the morning going in one direction, in the evening, for example, will go also in the other direction. Okay, so you will have two peak hour in the morning and in the evening. But if you use 24-hour trip matrix, usually they are symmetric, yeah, because when people go, usually they come back. Yeah, they need to go home. Okay, so remember in the network, the data is the demand and the network. Yeah, the network represent the supply. Yeah, the trip matrix represent the demand. So traffic assignment is where you mix the demand and the supply together. Okay, network consists of nodes and link. Okay, the node can be the intersection, and can be the centroid where you generate that demand or attract that that demand. Okay. In the links, you will have many properties. For example, the speed flow curve, the cost flow, and so on. Okay. These are quite complex. Okay. So the output, okay. Simplified output is just link flow. Okay. Once you get the link flow, because you know the capacity, you can get the congestion. So the link flow, okay, is basically equivalent to the congestion if you divide the capacity. Yeah? Because the value is zone by zone, okay, then you need to get the zonal travel cost little. Yeah. And then once you get everything, okay, the congestion level and the link flow, then you can calculate the everything else. So for example, you can calculate vehicle kilometer, vehicle hour, network delay, bus revenue, and so on. Okay. There are secondary output from the traffic assignment, which is actually you can also get the route estimation because this is actually internal. Okay. But you can also get that. Okay. And then you can also analyze which OD pair for that particular link if you go to the detail. Okay. So, and from there, you can get the percentage, how many is actually turning movement in each junction, in each intersection. How many percentage to go to the right, to go to the left, and go straight or U-turn. Okay, so all of these are secondary output which you can also get. Okay, so the network represented by graph. So when you have the real network like this, okay, then we simplify, okay, using graph. So graph is basically just node and links. Yeah, can be one no arrow or with arrow. Okay, so in transportation network, usually we use arrow because we have direction of the movement. Okay, so basic graph representation of transport network is directed graph. We call it directed graph. Yeah, when we say term graph, that means undirected. When we have arrow here, that's called directed graph. Okay, we can also have sub loop in here. So the node, sometimes in graph theory, we call it vertex. Okay, the links in graph theory, they call it edge. So just remember this is the same thing. Yeah? Edge is the same as link. Okay, vertex is the same as node. Okay, now if you want to study more detail, okay, network have some kind of topology. Yeah? So this is, for example, A, this kind of topology. C is like a star, and B is the usual network, and D is probably very complete network, okay? More complex, that all links is connected to any other links. So then you can start to see, actually, there are some pattern between the network topology and the connectivities. Okay, so say this is the network length and this is the average path length. Okay, so there are certain minimum networks here in A. Okay, because you can go, look, this is graph, that means two direction. Yeah. Okay. When I don't put the arrow, that means two ways. Yeah. So A here is the minimum network. Yeah. D is the most complete, yeah, network. So there is some curve, okay, that very interesting curve, because now you can see there is some kind of geographical barrier and the minimum network pattern. Okay, so the more you can connect one link, one node to another, that means you will get the fully connected network here. So that means the total network length is the highest. Okay, but you can also have the minimum network, which is just connecting all these dots by just one link. Okay, so we have also somewhere in between. Okay, based on this, now you can check the robustness of the network, for example. Okay, what will happen if there is flood? What will happen if there is a bagyo or a storm? Okay, then if you use A, of course, the problem is, okay, when one of these link is broken, so there is no other way, right? So the same thing in your network right now. Check, okay, what is the possibility that they can use alternative route? Okay, if they cannot use alternative route, then the robustness of the network is going somewhere near to the minimum network. So when that route, okay, when that link is congested, so you cannot move, they cannot go away from other place. So network topology is also a very interesting pattern that we can research. Okay, so now if you have connection like this, okay, then you can find the path. Okay, if I want to go from say 1 to 3, so you want to go, so these are the connection. Okay, but if you want to find the path, say from 1 to 3, so you go to 1 and then oops, to go to 3, 2, and then go to 3. Yeah. If you want to go from say for example, from node 1, you can go to node 2, right? From node 3, can you go to node 2? In this example, you cannot. Yeah? So, okay. So this is just connection, and this is the path. The path is basically you can trace where you go, yeah, from 1, 2, and then you go to 3. Okay. Okay. So next meeting, we will discuss route choice and shortest path. Yeah, which is next week. I cannot join, so on the 15th, let's move this to based on your vote. Let's move this class to 18. Is that okay? So the Friday 15th of November, we will move it to 18. Okay, and then we still have a class on 22. Is that okay? Okay. So we will go based on route choice and then shortest path. Oh, my connection is lost. Okay, so on November 15, I'm not around. Okay, so we will move our class on November 18 on Monday. Is that okay? Okay. And then on Friday, November 22, we still have class. That means next week, the whole week, we don't have class. Okay, so we'll make a makeup class 18 and 22. Is that okay? Okay. Now we have 30 minutes or 28 minutes. So can you present your progress in your group project? Anyone want to present first? Which group? Yes, June, can you present first? Yeah, good. Okay. Go ahead.
Sir, just an update to our group work.
Okay.
So we conducted already initial data gathering.
Mhm.
So we conducted an inventory for roads within the project site. So we documented around 20 roads,
Okay. Are
which
they connected to each other?
yes, sir. Some are perpendicular, crossing, and I will show that to the map later.
Okay.
So the red one are the traffic influence links. So we are planning to just focus on these links, sir, instead of including all the networks around the project sites.
Or it's better if you include all the network, and then you can focus on this link for the change, but you include the whole network. Is that possible?
Let's see, sir, but um, because we only have data in terms of traffic counts for this
No problem.
network.
Traffic count, you only need one road.
Okay.
Okay.
See, sir, we'll talk later with
Okay.
our group on how to do that. But anyway, so this is we're planning to focus on the 8 links, which
They
are
are connected.
major roads.
Okay. No problem.
So this is where the public utility vehicles are actually flying or routing. So we focus on these
Okay.
roads. We are planning on this. But if you suggest that we consider all the links within or near the project sites, we will.
No need to include the small road, that's fine. But can you connect this red part here so that they are fully connected?
Uh-huh.
So you need to connect. This one is like disappear. How about this part also? And this part and this part, right? So can you connect this part with something else? So probably you can create some kind of cloud node, which is represent all the links, all the place other outside here. And then you just put a dummy links to connect, okay, to the cloud.
Every influence
Every
road.
sync and source node. Yeah.
Okay.
This is fine, no problem. You don't need to include the small root if you don't want. That's fine. But can you include the dummy link so that you will get the fully connected network, strongly connected network.
Noted, sir.
Okay. Next.
Next would be. So we have the data on this because last year we conducted the traffic
Okay. So
survey.
can I know which link is this?
This one, sir.
Yeah. So only in Kalayaan?
Kalayaan, we have also
Okay.
the entire link. The
Okay.
one that I presented a while ago, the 7, 8 links, the red
Okay.
one.
Okay. Good.
So we have the initial data on that during AM and PM peak.
And then
So we have the figure
okay.
on the daytime and nighttime population of the development of the proposed development. So for methodology, I will call Joven to discuss.
Okay.
Hello, sir. Can you hear me, sir?
Yes.
Sir, so we are already done with part A, sir. We have already
Yeah, you
got
can
the
collect already.
data. Then we are currently through the IFN, sir.
Oh,
We are doing the letter
okay.
B now. We're already letter B.
Okay.
Using the data we gathered, we are still calibrating and modeling the baseline.
Okay.
So that's the part, letter B, sir. Then for our letter C, next slide, sir. We have the 2 scenarios, sir. The one, we will convert the Hippodrome Street into one-way.
Okay.
Okay, so we will decide on our group if we will retain the northbound only or the southbound only, sir.
Okay.
Depends on the baseline, sir.
Okay.
Okay. Then we will, using the model that we did at letter B, we will simulate or implement the one way. We will change the whole baseline so we can know what will happen. We will evaluate the effects on the streets that are connected to that hippodrome street, sir. So what will happen to the links? Then the other scenario, sir, scenario 2. Next slide, sir. There. We will, the other solution that we are thinking is we will retain the two-way scheme on hippodrome, but we will do road widening, sir. Since of the circuit area is
Okay.
we can extend the lanes, sir.
Okay. So
So yes, sir.
can I give comment?
Yes.
Sometimes, okay, when you learn later on, maybe next week, or no, after 2 weeks from now, okay, after you learn the IFN, you start to see that road widening is not the only solution. Sometimes you can put road narrowing, right, instead of widening, you will get better result. Can you believe that? At first,
So
you
we
may
will
think
change
that this
this
is
scenario, sir.
not correct, but when you start to compute the whole network instead of just one link, then you will start to see that the traffic can be controlled, okay, by changing the number of lanes. I hope you can also include
So
narrowings in certain
so another scenario, sir.
Yes.
So 3 scenarios, we will try the 3 scenarios, sir.
Yes. So which road you can narrow, and then it will actually produce better result. So at
Okay,
first
sir.
you
We'll
may
try
think
the
this
third
is
one.
not
This
possible,
actually,
but you can try. It is possible.
okay, sir.
And rerouting also.
The routing is already there inside, so you can put it out. Yeah. And you can schedule with me a special consultation, your group only, and then you can I can show you how to use and so on if you want. This is optional, but if you want, you can schedule.
I see.
Okay.
Yes, sir.
And then,
So that's our next steps already, sir.
okay, good.
Then
I-
after,
And then,
Sorry.
sorry.
Vince did the initial simulation of
Oh, okay, so you get it.
the
All right.
network. Yeah.
900 nodes.
Okay. Zeroing in, sir, on the yes, sir.
Okay.
Based on the picture as shown earlier, we just use the OSM on that extent, which
Okay.
is this given coordinates here. This already include the residential street. So if we remove the residential street, the number of nodes and links will be minimized.
Much lower. Yeah, much lower. Right.
Yeah. So on the residential street or pedestrian street level.
You can reduce that network into a much smaller as you want.
Yes, sir.
Okay.
Actually, if we also consider what you advised earlier, the network will be much simpler. So
Yeah.
this one can be a sync.
Right.
The sync, it can be a source sync node
Right.
altogether, the circuit area, and then the outside can be also a sync node or a cloud node.
Okay.
Okay. On the next slide, it's just the initial results, the overall network results on that
Okay, so
that network.
wait, I will highlight here. This is the one that you need to record.
Sir, we use real flow app actually based on what June has presented earlier. We
Okay.
assign the flows vehicle per hour on
Okay,
the
so
links.
If
I
you
repeat.
use trial flow, did you get the exactly in that link that you calibrate that exactly the same or more or less the same in link? So
No,
check.
sir. We get higher.
You get higher, much
IFN
or just
return higher.
significantly higher.
I think so. Maybe I can share the screen for the Excel sheet of that one.
Okay.
Here. Is it showing now, sir? Here. This column here is the flow as returned by IFN. This
Okay.
is the actual flow assigned on the link. For
Significantly
example,
higher.
this
That's
one.
not
Sir?
possible. That's not possible. Significantly higher.
Yeah, for this particular link, sir. But on
But
the
that's
other link,
particularly only. But the others, this is the one that you
but the
put.
other links are very close.
Okay, the other link is very close. That's okay. In that case, it's fine. Because
Yes, sir.
because
But
these
this
are
one
based on
also,
average, right? So
yes, sir.
yeah.
If we look at it, on the links having capacities of 3,000 to 4,500, the IFN overestimates it, I think, here. But on the significantly higher capacity links, it is close,
Okay.
usually close.
Right. So next, what you need to get is actually the total flow in the network.
Total flow.
Yeah, the total flow in the network. Okay, that is the assumption that you will put. It doesn't change. When you want to go to alternative 1, alternative 2, alternative 3, okay, that total flow does not change. That total
So,
flow
sir,
represents all
but
this.
would we need to focus on the links that we know the volume already?
It's up to you. The focus is up to you. Okay. If you want to compute the alternative 1, 2, 3, in order to make them the same, okay, the total flow must be the same. Do you get the
Total flow.
idea? Okay, show me again the screen that a while ago. The IFN result.
Okay. Sir Jun, please.
This one.
Here, sir.
Okay, so here, yeah. So look at this, okay, for all also. Okay, look at this total flow. This is the one that you copy and paste.
Yeah,
Okay, and then the next one that you want to see is actually the maximum congestion level. What is that? What?
This one.
Something is wrong with your computation. It's impossible.
maximum is around
1,500%? No.
percentage. Yeah, that's 15 folds.
Percentage.
Yeah.
Something still wrong in the computation. Okay.
We'll reset this.
Yes, sir. We'll rerun this actually. We flagged it as dubious actually when we're discussing among the team.
No, not possible this one. So say you have it. If you have your data, okay, then you put it inside. Suppose you get a certain congestion level, okay, and put the total flow here, okay, and this is the one that you assume fixed. And then you now next one you check whether the congestion level in your alternative scenario reduce. but this is already impossible number. So something still wrong. I don't know which one. So probably some of your data is incorrect. I don't know. Okay. So yeah, we need to investigate more detail in this case. So you can share with me the data. I can also help you to investigate. The one
sir.
you share is just go to this network, right? You go to the networks tab, and then there is a save there. You can save and then send to me the scenario in the IFN format.
Okay, sir.
Okay.
Okay, we'll
I'm going to
email
use it.
the CSV file, sir.
JSON file, I think.
Okay.
Okay.
We'll rerun the network simplified one, sir, before we send it.
Okay.
I think this will be the last slide, sir.
Okay. Yeah. So thank you for the update. Okay.
Thank you, sir.
Okay. Let's discuss some other time. So other groups, go. We have two more groups. Yes, Claire.
Good evening, sir.
Yes,
So, Glycerin and I will be showing our update as well with our project. I'll just share my screen.
mm,
Is it visible now?
yes. See you.
Um, so we already chose a specific route for our study is to identify the optimal bus efficiency for several routes for delivering sakay of QC. So initially we proposed seven routes, but we already identified route 2 as the study area. So these are the data that we have gathered so far.
Mhm.
We have chosen route 2 specifically because it has the most number of trips and the most number of total ridership. So we want to make sure that that uh line is optimized. So we have the distance at 8.5 going to this is the starting line, and then going to E.
Hmm.
That's 8.5 and 10.10 coming back.
Mm.
There are 180 number of trips
Trips.
in the week.
Okay.
Yes, sir. And
Wait. The trips mean round trip or one-way trip?
this is round trip, sir.
Okay. So for example, from QC City Hall until here and then come back.
Yes, sir.
Okay.
And then there are 15 authorized number of buses. So along this line po, there are 5 stops. Sorry, 5 stops that includes the first one and the end stop. The end. This one at E.
Okay.
And we also identified the seating capacity per bus.
Mm.
We also have the schedule and the estimated travel time for each on the weekdays and on the weekends. And uh, the travel time for peak hours and off-peak hours, the total ridership, and the ridership per day.
And so these are all data, right?
Yeah, yes, sir. You suggested when we had the consultation that we'll use the AADT
Yeah, if you have.
for Commonwealth. So
Mhm.
we identified one for 2023. I'll just show this briefly, sir, the base case scenario that we have made. So since we only have 5 nodes and 8 links,
Okay.
so I'll show you the one I did using the IFN.
Why you need
So this is
IFN?
sorry, sir.
I mean, why do you need to use IFN?
Because we're trying to get the congestion. We wanted to show the base case scenario without the interventions.
Okay.
Wanted to propose for the buses, assuming that we also have a question for that because we assumed the congestion would be, I mean, the number of total traffic that goes through the area would affect the turnaround trip of the buses.
Mm-hmm. And then,
So based on this, the number of lanes along Commonwealth is 6 lanes per direction.
Mhm.
So is it right, sir, that we use the 6 lanes or do we have to use the 12
no, for directions.
per direction? Yes, sir. And when you enter along on the Batasan route, there it will be reduced to just 3 lanes.
Mm.
For the distance, this is also the distance per segment of the route.
Okay.
And we just use the maximum speed for Commonwealth and Batasan area.
Mm. Can you get the congestion from here?
Actually, sir, because we don't know really how to proceed, so we just assume that the congestion based on the IFN traffic assignment tutorial is at 0.9.
No. You can calculate the congestion from here because you know the capacity. Okay. And okay, so you can assume we can calculate from here. You can calculate the flow if you know the total flow, or you can assume 0.9 as the maximum congestion level, and then you can
Yes,
get
sir.
the flow. If you put this the same thing in the congestion matrix, do you have?
Sorry, sir.
If you have the congestion matrix similar to this capacity link distance, if you can calculate the congestion matrix, say you assume maximum congestion 0.9, okay, if you can see the congestion matrix, that will be very interesting result. Because now you will see that, for example, the 6 lane probably okay, the 3 lane is not okay, or something like that. So we can start to see.
We'll just revisit the
We just
con-
calculate the congestion matrix
Yeah.
based on
And the
the
flow.
yes,
Yeah.
sir. Yes, sir.
Yeah.
yes, sir.
Next.
For the next part, Glycerin, do you want to proceed?
Uh, Next slide, please. Basically, these are just descriptive analysis
Yeah.
for our paper. This is the outline of the descriptive analysis. So first we'll describe the route characteristics, the current operational setup of the libreng sakay,
What is the
the
goal of the
passenger.
study, Leslie?
First, sir, it's under our analysis approach. So we're going to we have two types of analysis that we're going to do, the descriptive and the correlation one.
Okay,
So
so
this is just the
yeah, this is the usual. Question is, what is the
yes.
actual goal? What kind of policy that you will propose?
Um
Okay, you got identify the key factor and what kind of operational improvement you will propose. They have something that, you know, this is your hypothesis, right? So I want to see what kind of proposal that you, given all of
yes,
this
sir.
and given the analysis, what will be your operational improvement to achieve?
Yes, sir. So maybe after identifying the level of congestion on the lane, so we'll be able to project service adjustments such as increase fleet size or enhance frequency of the adjusted schedules of
Okay,
the
so
buses like that.
frequency and the number of fleet size.
Yes, sir.
Okay, good. So
Although, sir, sorry, I have to mention because I did a quick interview with the department that handles this. And we do have, you mentioned when we had the consultation that we need to do the sensitivity analysis.
oh yes.
So we had a bit of a problem because there's budget constraints for it. And we also at least wanted to put charging. To charge, I mean the passengers that are using it. But then the person I talked to mentioned that Quezon City is not a transport I forgot the term, but they are not allowed to charge
Okay, so
for
no problem with that. So can you create a model, say mathematical model that will include this goal? Okay, so the number of frequencies and then probably the number of fleets.
the number of fleets,
Okay,
sir.
all right.
Yes.
So
And then we'll have to just mention those constraints that we have.
no, those are the input that you will put, and then I want to see the output. What will be the say your output will be efficiency, right, or reducing the congestion. So I want to see the connection between the input and the output. That is the one that you will put
Okay,
the
copy, sir.
sensitivity analysis. Okay, for example, if you increase just by
Copy, sir.
one bus, or if you increase by 1 minute, okay, what is the improvement in efficiency? What is the improvement in reduction of congestion? That is the one that we want to know. That is sensitivity analysis, right? Anyway,
Yes, sir.
yeah, if you need some more consultation, you can schedule again.
I think, sir, what we need is someone to actually guide us with the computation because
yeah. So we need to go to the detail. In that case, we need to spend some time with the consultation later. Okay? Let's schedule that.
yes, sir. And if
Sir.
also we wanted to ask some of our classmates if they can tutor us on the computations as well.
Yeah. So if anyone want to help them, so there are only two. Many of you are four. So their members leave the class. So if you can help,
Thank you, sir.
yeah, it will be nice. Okay, one more group, right? Will present, is it okay? Or you want to present it next meeting? This is already it. Okay, go ahead. Reference. And
Hello, sir. Good evening.
yes,
So we're the last group, and our
we are
research
not
is about
students.
the traffic impact assessment of the proposed mixed-use development in Pasay City.
Mm.
So this is the project information that we have gathered.
Mhm.
So the project launch about to start this year, maybe last quarter, according to my friend of mine, which is working in the developer side. And the target completion will be on October 2032. The gross area is about 32,761 square meter, and the construction floor area is about 254,000 square meter. And there will be a parking slots, which about 1,812 for a total of 10 towers. And there will be a 1,813 residential units.
Mm.
So for the traffic analysis zone, we just limit our study zone with a radius of 500 meters only. So the MetLive 3 is the name of the proposed project, and it's located at the center of the circle.
Wait.
And
Can you include this main at least this main road?
okay, sir.
Yeah, this road.
Oh,
This
so meaning, sir, I need to increase the radius of
a little
the
bit, yeah.
study area already.
Yes.
Because we're trying to limit the number of intersections, because currently if we use a 500 meters radius, we only have at least two major intersection, the Macapagal Avenue and EDSA, and the Rojas Boulevard EDSA. But if we try to increase into like 1 kilometer radius, the intersections will be like 8 or 10 intersections already.
That's fine. So you are doing a traffic impact study, right?
Yes,
So,
sir.
and you don't need to consider the small road, only the major road is fine.
Okay, noted, sir.
Yes.
Yeah, we will revise this traffic analysis zone.
I worry if you use only 500 meter, it seems okay, but you will get the problem in the other place.
Is it okay, sir, if I increase to 1 kilometer, at least
Yeah,
1 kilometer from
yes,
the focal point? Okay.
yes.
Then currently, we are still waiting from MMDA regarding the data for our baseline traffic count. But nonetheless, we also conducted a manual traffic count at one of the intersection, which is
Okay.
the Macapagal Avenue and EDSA. And we found out that about 55% belongs to private cars, followed by motorcycles, public utility vehicles, and trucks, and these LCVs. So this is a manual traffic count that we conducted last November 3 from 8 to 9 a.m. in the morning.
Wait, can we go back to the first slide? Is it okay? Before this, the one that you put the numbers. Yeah, this one. So from here, from this data, this is very important data. Okay, this one. Can you calculate the trip gen?
Okay, sir.
You just find the literature, what is the trip rate for this, and then because you have the square area and so on, so you will know
Mm-hmm.
actually how many traffic will be generated from here and attracted to this also, because you have retail shop. You need to know what is the areas here of the retail shop and the parking areas. Or parking area you already have, right? So from there, you can actually calculate the trip attraction and trip production. Is it okay?
Okay, sir. So we can just use the standard, like for example, for classification of residential, there will be a corresponding produced and attracted
Correct, right,
trips.
correct,
So we can just use that rate.
correct.
Okay.
And then multiply by these numbers.
Okay, noted. So no for us to conduct a manual traffic count
Manual
on
traffic
the
count is
area.
better for just to compare. Okay,
Oh, for
you build the
comparison purpose
model,
only.
after you build the model, you will compare, right? Whether
Uh,
your result is the same or not. Like that.
okay, noted, sir.
Next.
And for our methodology, as a team, we are still brainstorming and trying to enhance our methodology. For now, this is our draft methodology.
What will be the policy that you will do if surely there is a congestion here after you, you know,
Maybe the recommendation that we can give is especially to the LGU of Pasay or to the management of the proposed construction is maybe the conceptual traffic managed plan during construction and the conceptual traffic managed plan during full development.
and after development.
Yeah, after the development.
So what will be after everything is developed, there will be very congested area there.
Yes,
So
yes,
how are
sir.
you going to cope with that? Isn't that supposed to be the goal of TIA, traffic impact assessment? You're supposed to give what is the strategy once it's fully developed, not only during development, but once it's fully developed, what will be the scheme? So,
Noted, sir.
yeah. So for example, the signal timing, traffic signal timing, you can adjust. Or maybe you will make it one way or during certain
Maybe road widening.
or maybe road widening if you
Yeah.
need. So depends on the demand that you calculate, right? So I hope I think this is the most important part. So what is actually the traffic management strategies that you will propose? And then for each strategy that you propose, you calculate based on their model, right?
Noted, sir.
So that we don't just say, but okay, qualitatively, but we actually give the quantitative result. That is the purpose of modeling. Okay. Okay, so you can use the classical one. Okay, so trip gen, trip distribution, mode choice, and traffic assignment, no problem. Okay, thank you for today.
Okay, sir.
Sorry,
Thank you.
the time is past 8. Yeah, so if you want to have consultation, separate group, so you just schedule it with me. Okay, give me several choice of time, and then we will have a Zoom meeting separately. Yeah. Next week is fine, and then we can have a separate meeting. Only Thursday and Friday I'm not around, or Saturday, but the others is okay. Thank you. So see you on 18. Okay.
Hi, sir.
Thank you, sir.
Thank you. Bye bye.
Thank you, sir.